मेरा नाम शैलेंद्र राठौर है और मैं दिल्ली विश्वविद्यालय से परास्नातक विद्यार्थी हूँ और साथ ही साथ ग्रेजुएट स्कॉलर्स टॉक सीरीज का एक मॉडरेटर भी हूँ। What began as a modest effort to create a space for dialogue, ideas, and intellectual exchange has today grown into a remarkable journey of 271 conversations, each adding a new layer of insight, depth, and collective learning. As the moderator, it is my honor to open today's gathering and acknowledge the efforts of all speakers, participants, and supporters who have made this journey possible. The GSTS talk series returns with the same spirit that has always guided it, rooted in traditional yet open to fresh ideas. This series celebrates the conversations, reflections, and collaborations that have long shaped the creative and intellectual identity of the GSTS community. Created to honor a shared legacy, the Graduate Scholars Talk Series welcomes scholars, educators, and thinkers whose insights continue to enrich our platform. As they share their ideas, their voices contribute to a larger journey of learning, continuity, and collective growth. कोविड काल की कठिन परिस्थितियों के बीच 7 फरवरी 2021 को डॉक्टर मनीष कर्मवार ने श्यामलाल कॉलेज इवनिंग की इतिहास सोसाइटी साक्ष्य के साथ मिलकर ग्रेजुएट स्कॉलर्स टॉक सीरीज पहल की शुरुआत की और इसका उद्देश्य था विभिन्न मुद्दों पर संवाद और ज्ञान विनिमय के लिए एक खुला, लोकतांत्रिक और सभी के लिए उपलब्ध मंच तैयार करना। देश के अलग-अलग क्षेत्रों से जुड़े वक्ताओं ने अपनी उपस्थिति, अनुभव और विचारों से इस मंच को लगातार समृद्ध किया है। उनके योगदान ने विद्यार्थियों के ज्ञान को विस्तृत करने के साथ-साथ महत्वपूर्ण विषयों पर बहुआयामी सोच को भी प्रोत्साहित किया। इन्हीं प्रयासों के परिणाम स्वरूप पिछले 5 वर्षों में जीएसटीएस ने 271 वार्ताओं का उल्लेखनीय पड़ाव सफलतापूर्वक पार किया है, जो इसके सतत विकास और स्वीकार्यता का स्पष्ट प्रमाण है। जीएसटीएस इस विश्वास पर आधारित है कि युवा शोधार्थी ही भविष्य की ज्ञान धारा का निर्माण करते हैं। उन्हें अपनी शोध, विचार और अनुभव साझा करने, सार्थक प्रतिक्रिया प्राप्त करने और नए बौद्धिक आयाम खोजने का अवसर देना, इसी सोच से यह मंच अभी तक बढ़ता आया है। और यही कारण है कि जीएसटीएस आज एक सक्रिय और जीवंत शैक्षणिक समुदाय का रूप ले चुका है, जहां संवाद, सहयोग और नई दृष्टियों का उदय सतत जारी है। It also gives me immense pleasure to acknowledge the remarkable achievements of this initiative. Over the years, it has been honored 3 times by Doordarshan and has also been received recognition in the Times of India under the G20 Changemaker Summit at international platform, which was one of our sessions was broadcasted live and further amplifying the reach and impact of our work. Alongside these recognitions, we have also forged meaningful collaborations with educators and academic institutions across the country. And these accomplishments stand as a strong testimony to the dedication and vision and consistent efforts of the GSTS team, and the team comprises the founder, advisor, the all-in-all of our team, Dr. Manish Kanwar, and the moderators, Mr. Rajay Gupta, Mr. Shubham Tiwari, Mr. Saurabh Singh, Ms. Manvi Saraswat, Ms. Samriddhi Kanpal, and Mr. Manthan Tarle, whose Mr. Manthan Tarle, Ms. Shrishti Rajput, Mr. Ankit Kumar, whose contributions have been essential to the growth and success of this initiative. Now, when I introduced you all to very elaborately to this initiative, it is time to very warmly and very respectfully welcome our today's guest of honor, Dr. Sarika Yadav ma'am, as our guest of honor for this 272nd session. मैम आपका बहुत बहुत स्वागत है एक बार फिर से ग्रेजुएट स्कॉलर्स टॉक सीरीज में एंड यू आर मोस्ट वेलकम टू दिस प्लेटफॉर्म वंस अगेन. Now, before I invite you for your initial remarks and for your permission to proceed the session further, मैं आपको इंट्रोड्यूस कराना चाहूंगा हमारी आज की ऑडियंस के साथ. So, Dr. Sarika Yadav ma'am is an experienced academic and researcher currently serving as assistant professor at Institute of Professional Studies, University of Delhi. She holds a PhD in computer science and engineering from MNNIT Allahabad with an excellent CPI of 9.0 and with over 10 years of teaching experience and research experience. Her core areas of expertise include wireless sensor networks, artificial intelligence, algorithms, and network survivability. She is a gold medalist in MCA and UGC NET qualified. She has published several research papers in reputed SCI indexed journals and IEEE conferences. Four of her research papers are presently under review in SCI journals, and she has also qualified the prestigious WOSC Women Scientist Team. And Dr. Yadav actively contributes to curriculum development at the university level, and she regularly serves as a reviewer and session chair in international conferences. And she has delivered invited expert lectures in faculty development programs, and her academic career reflects a strong dedication to teaching, research, and academic leadership. Now, I would like to invite you, ma'am, for your initial remarks and for granting us your permission to proceed the session further. Ma'am, you are mute. Kindly unmute yourself.
Yes. Thank you so much for inviting me and again making me as a guest of honor in this session. I'm really thankful to Shubh for providing this new new attachment with this group. Again, I would like to say that yes, this platform is very good for the graduate students, especially who wants to do some research and wants to share their thought. But I would like that more and more people should get attached with it. I had tried my best with my students also to share this platform, but nowadays the generation is like that. uh, when they are not getting anything as a in form of certificate and just ask what is the use of it in the career. So I think this platform should provide at least a certificate to the students who represent here as a researcher. It's my humble request to Manish, especially. So once again, I congratulate whole team for this new initiative. And please, I request all of you to start the session. Thank you so much for calling me
Uh,
again. Thank you.
Yeah, thank you. Thank you so much, ma'am. And just a quick like information that we do provide certificates, ma'am, from on
Okay.
the behalf of yeah, we do provide certificates on the behalf of Chamlal College Evening University of Delhi to all our participants, and we also do provide a very special certificate and memento to our speaker of the month. For a certain month, we choose one speaker as speaker of the month, and we do provide a memento and a certificate
Okay.
as a small gesture of
I was
appreciation
not
from
aware
us.
of it. So sorry for it. So sorry
No, no,
for
it's completely fine, ma'am. It's completely fine.
it.
And again, thank you for accepting our invitation and joining us today. And now it is time to invite our today's speaker. And now I'm welcoming, inviting, and handing over the screen to Mr. Shubh Shankidhar. He is a postgraduate scholar from Center of Computer Sciences, University of Allahabad. And today he is going to speak on the topic Beyond Words, visual speech recognition, AI, and the future of human communication. Um, so now I'm handing over the screen to you, Mr. Shubh.
Thank you so much, Shailendra sir. Let me present my screen first. So yes, very good evening, everyone. I welcome you all to this session, and also I am grateful to you all for joining this session today. So myself, as sir introduced me, myself Shubh Sankidar, and I have done my post-graduation in MCA from University of Allahabad. Now I have been engaged into research in this research visual speech recognition under the guidance of Dr. Sarika Yadav ma'am. First of all, I want to express my most humble, most sincere gratitude to the GSTS team, especially Dr. Manish sir and the whole GSTS team for providing me this opportunity again to speak on this platform, to come on this platform again. Thank you so much, sir. Thank you so much, GSTS team. So today, what our mission is, today we will try to explore a very fascinating question. Can machines understand speech without the sound, without the presence of the sound? And if yes, if machines can understand without the presence of sound, then what does it mean for the future of human communication? So we are going to explore the beyond words, visual speech recognition, AI, and the future of human communication. But a very valid question should arise first. After all, what is the need of this visual speech recognition? Why should I listen to you? Why should I focus on this? Why should I know about this? What is the need of this visual speech recognition? Most of us, we think that communication is bound only with the sound. It is done only through the sound. But there are also some cases, there are some scenarios where sound becomes unreliable, sound becomes risky, or even sound becomes unable to be produced. There are situations where sound is not uh, impossible to be produced. So, what if the communication breaks down? What if the sound on which we think that communication depends, that communication relies, what if it becomes unreliable? What if it becomes unreliable to depend upon? What if the communication breaks down? Now, what are those situations? Just imagine a noisy environment, example, some battlefield, a soldier in a battlefield where speech cannot be heard. A soldier wants to communicate, a soldier wants to speak, wants to convey the message to another partner, but the speech cannot be heard just due to the noisy environment of battlefield. Or a person who is not able to produce the sound. There is a possibility that the speech impaired person is not able to produce the sound, and there can be a scenario where a CCTV video footage has only the visuals. What if it is needed to be produced before the honorable court as some evidence, but there is no sound? You just consider the scenario of the movie Simba, where the police officer takes the advantage of no sounds, only visuals in the CCTV video footage. Or a soldier went to some enemy country for some secret operation where sound producing sound becomes risky. Yet, in all these situations, there exists the need to communicate. There exists the need to understand each other, to convey the message. But sound is becoming unreliable. Either there is no possibility of producing the sound, or sound is getting produced, but it is not getting understood by the person, or there is no there that producing the sound becomes risky. And that leads to the fascinating question: can there be some artificial intelligence system? Can there be some machine? Is it possible for the camera of my mobile? It is possible for the glass I am wearing. Can there be some smart glass that can interpret the speech visually? That can help me communicate visually without the presence of any sound, where sound becomes unreliable. Now, we humans have already came a very long way. We have evoluted we have faced the evolution from the very cave paintings to letters to the telecommunication. In all these traditional systems, what what where does they fail? कहाँ पर इनमें चूक होती है? So they are dependent on the speech. And I have already shown you that there are scenarios, there are situations where producing the sound is not just possible, it becomes unreliable. The second, it is impacted, highly impacted and affected by the noisy environment. Even if sound is able to be produced, you can't understand the sound in a noisy environment. Just take the scenario of Huda City Center at in Delhi Metro Station or the Mandi House. Delhi metro station. You can't understand a person standing 100 meters away from you. Why? Due to the noisy environment. The third, the information loss. It is very well said in Hindi. It's a proverb, a local proverb that देखना सबसे बड़ा प्रमाण माना जाता है, कई बार कान धोखा खा जाते हैं। तो ये जरूरी नहीं है कि जो मैं सुन रहा हूँ, जो साउंड मुझे मिल रही है, वही पर्सन कहना चाह रहा हो। तो अगर हमारे पास कोई ऐसा तरीका हो जहां मैं विजुअली उसको वेरीफाई कर सकूं, देन द इंफॉर्मेशन बिकम्स रिलायबल, then the communication becomes reliable. And the fourth is the surveillance system. There is a need जहां पर रिस्की सीक्रेट ऑपरेशंस में, जहां साउंड आप प्रोड्यूस नहीं कर सकते, वहां पर आप कम्युनिकेट कैसे करेंगे? So this is a scenario where the traditional systems fail. Then what arises? What we will explore today. We will explore, can machines understand the speech visually? The speech which we are trying to understand through the sound, can machines understand it visually? We will try to explore how AI, artificial intelligence, learns the human communication patterns. We will try to understand what this research exactly improved in the existing system. And the last, the what will be the future of human communication. Now, the first question which arises is, what exactly is visual lip recognition? So, visual lip recognition, if I say in simple words, is a very developing field of artificial intelligence where you give the video input to some artificial intelligence system. It crops out your lip region. It processes that lip region, the lip video, and it gives you the output in the form of the text. Just simple. In simple terms, we can say it where the machine tries to understand your lip movements, how my lips are moving. If I just
Unmute yourself. Subh, unmute yourself.
Yes, sir. Actually, I was trying to say, when I mute myself, what you will do? You will try to interpret the movements of my lips. That is exactly what visual lip recognition is. In the lip recognition, you feed a video to the AI system. It crops out your lip region because it is what it deals with, and it crops out the lip region part, and the AI, backend AI, the model which is trained, processes it, and it gives you the text in the text output what the person wants to say. No sound. It does all visually just by seeing the movements of the lips. Now let's understand how it works. See, the machine learning, the artificial intelligence, in simple terms, if I say, although it is much broader, but in simple terms, if I say AI and ML is just the imitation of how I behave, of what the capabilities, the abilities a human has. So, in machine learning is the imitation of the abilities of the human. So, let's understand through our own example. I want to request the audience, don't focus on Ram Charan playing with Alia Bhatt, just focus on the topic that there are two persons trying playing the Chinese whisper game. Now, suppose you have seen the video, or you might have played the Chinese whisper games where we apply the headphones on our ears, and then one person tries to say something, and the other person guesses how the person guesses, by seeing by interpreting the lip movements, the movements of the lips of the person who is saying. How humans naturally do it? Humans try to see the lip movement. What I will do, मैं सबसे पहले ये देखने की कोशिश करूंगा कि कैसे उसके होठ हिल रहे हैं। हर धीरे धीरे मैं उसको इंटरप्रेट करूंगा, मेरे आईज अब मेरे ब्रेन को फीड करेंगे द फ्रेम बाय फ्रेम विजुअल, कि क्या कैसे कैसे लिप्स की जो मूवमेंट्स हैं, जो शेप है, वो चेंज हो रही है। यूजिंग दैट विद रेस्पेक्ट टू द टाइम, जो लिप की शेप है वो कैसे चेंज हो रही है। यूजिंग दिस विजुअल, जो मेरा ब्रेन है वो इंटरप्रेट करने की कोशिश करेगा कि ये जो मूवमेंट है, जब मेरा होठ खुला, जब मेरा होठ बंद हुआ, जब मेरा होठ इस शेप में आया, तो ब्रेन विल ट्राई कि ये जो मैंने शेप देखी है, ये तो नॉर्मली इट करस्पॉन्ड्स टू सच एंड सच करेक्टर। तो इन दिस वे द ब्रेन विल टेल मी, okay, the person might be saying this and this. The person might be saying University of Allahabad. The person might be saying University of Delhi. In this way, we humans try to guess using the lip movements of a person. Now, similarly, how the machine, or how the machine learning, how the artificial intelligence, how the machine learning model does it. Now, let me tell you one thing. Machine learning is not about some exact on or some simple algorithm जिसको हम अप्लाई करेंगे और हमें सॉल्यूशन पे हमें सॉल्यूशन मिल जाएगा किसी प्रॉब्लम पे. जस्ट फॉर एग्जाम्पल, अगर मुझे कोई क्वाड्रेटिक इक्वेशन के रूट्स निकालने हैं, तो मेरे पास एक सिंपल सा फॉर्मूला है, श्रीधराचार्य फॉर्मूला, और वी कैन से क्वाड्रेटिक फॉर्मूला, जिसमें मैं जिसके यूज करके अपने इक्वेशन का यूज करके मैं रूट्स फाइंड आउट कर सकता हूँ. बट मशीन लर्निंग इज नॉट लाइक दैट. मशीन लर्निंग में वी डोंट हैव सम फिक्स्ड एल्गोरिथम. हियर व्हाट वी हैव, the experiments, the capability to do experiments. We just go on with the experiments, and then we see what how the output is changing, how the accuracy is changing. So machine learning depends on the number of experiments. So we started with the very basic baseline model architecture. What we did, we referred to the 2016 published research paper in IEEE, where they introduced the LibNet model architecture. It's just the name. Don't think about it. It's the LibNet model architecture. So we first tried to imitate that model architecture just to develop a baseline model so that we can develop it more, so that we can upgrade it. So let me explain the baseline model architecture to you, the LibNet architecture, how it works, relating with the how human interprets it. So first, it will take the we will give the audio out, the video input to the model, to the model architecture. It's then it crops out the lip region as the human does. Human focuses on the lip region. If in the Chinese whisper game, similarly, a machine learning model in order to focus on the lip region, it crops out the lip region part. Then what it does, it it interprets the lip movements, the shape of the lips. It learns the shape of the lips frame by frame. Suppose in a video there are 75 frames, so it will look at each frame, and it will just store the patterns. How the what is the shape of the lip? What is the width of the lip right now? What is the height of the lip? What is the length of the lip? What are the edges of the lip? What are the how sharp are my lips? Are the teeth visible or not? Uh, or the lips are up or down? In the form of three layers, it will try to understand, it will try to store these patterns, how at each frame the lip shapes are. And then in it will transfer this information in the form of a feature map to the third step, to the third layer of the model. It will flatten it and it will transfer in the form of a single list to the third step of the model, which is sequence modeling. Now, what is sequence modeling? See, if I just tell you, you can't tell me what I was speaking just with the one glance of frame of a lip. So what is the third step? Third step is it combines all the frames and it sees what sequence is forming. What is the pattern if I play all the frames together? What is the pattern which I can see? Like one frame is, so in this way, it will try to interpret, it will try to see what is the sequence which is being formed if I play these number of frames. It is done in the third step. Now, the fourth step is it feeds these context aware, the feature maps to the fourth step, and fourth step tries to predict what character is possible at each time frame. At each frame, what character is possible, and in the fifth step, it tells us what is the sentence that the person might be saying. In this way, the baseline model architecture works, which we developed just by imitating from the research paper. Now, what is uniqueness? Am I just narrating the 2016 research paper here? No, we found some limitations here. What were the limitations? Where the baseline LibNet architecture actually struggled, it actually struggled first in frequent missing characters. As you can see, I have given some example. The ground truth. Ground truth means what was the exact sentence, the actual sentence. The actual sentence was set blue at F4 now. This was the sentence spoken by the person in the video. Now, what the model predicted set blue at 4 now. Did you notice what it missed? It missed the single character F. And this is known as the deletion error in baseline LibNet architecture. And what is the percentage of this deletion? The percentage of deletion of characters are 9.39%, which is very high in machine learning. And the word error rate is 21.59%, means how badly it is predicting the words, how badly it is predicting the characters. So, what the first area where the baseline architecture struggled was it was missing frequent characters. Second, the model size was too long, too large, too large. Why it is not compatible? Because I was focusing on the smart glasses. Just imagine, can I run your Instagram app on your smartwatch? No, obviously. Why? Because Insta app needs space to run, which mobile operating system has. But a small smartwatch does not have that much memory space. Similarly, if I want to integrate my model in just a small smart glass, in a wearable glass or a smartwatch, I need some smaller model, but no compromise in accuracy. This model has a good accuracy, but where it compromise, it has a very large number of parameters, a large size, which is not suitable for IoT devices. The third is weak prediction strategy, that the model was able to learn the patterns, but it was not able to predict completely. That's why we see the error rate of 21%, which is a massive, massive error rate. And the fourth is there was no contextual guidance to the model. What is it? For example, if just say if I am trying to predict in a Chinese whisper game, if I am trying to predict what the person is saying, and the person is speaking German, and I don't know anything about German, can I predict? No. What I will predict? Only blah blah blah, or all useless, all worthless. Similarly, if my model doesn't know about what the language is, if it doesn't know what Hindi is, what English is, how is it possible कि वो उसको बहुत अच्छे से predict कर पाए कि ये English में क्या sentence predict कर रहा है? So there was no contextual guidance provided in the baseline LibNet architecture. So we had two research directions. What research directions we had? First, improving the prediction quality, because we already saw that model is learning well. Model during the training, model is learning well, but where it is struggling in the prediction part, while it is making the prediction out of the lip movements into the text. Second direction of my research was that I should try to improve the model itself, complete model, a complete new model. So there were two directions. First is improving the prediction quality, which is in machine learning is known as decoding. And the second, improving the model itself. That means the architecture improvement. So what I did, I implemented the beam search decoding. I will tell later what is it. And the major is language model. I associated a language model with the model. That means now the model has the knowledge what English is, what the grammar of English is, in order to predict the sentences properly. And the second is architecture improvement. Now, what I improved in the model architecture, let me show you. So this is the comparison, the parallel comparison of what was baseline architecture. Remember, the baseline architecture is what was derived from the research paper, and model B is the architecture which I tried to develop. So where I changed at two steps. First is, as you can see, the flattening. What is flattening? In what it means in English? Flattening the thing, flatten the thing. In the same way, the what the model was trying to do, it was since by LSTM, matlab, this layer needs a smaller output, but this layer was generating a larger output. So what was the solution? It was flattening the output. Before transferring the output, it was flattening the larger output to a smaller output before transferring to the pi LSTM. It was the problem. Why was it the problem? Because due to this, the model was getting increased in terms of size. It was getting increased in terms of complexities, which I want to reduce. So what I did, I replaced it with the gap plus dense layer. What gap plus dense layer is? Gap plus dense layer doesn't flatten the output. So how it transferred to the by LSTM because by LSTM needs the smaller output. It maintains all the required information and it flattens the output. But what is the difference? It maintains all the required information before transferring to the by LSTM, resulting in what? In reduced size of the model, which I wanted to do. It reduced size of the model, and how much it reduced? The baseline architecture was having 8.9 million parameters, but the Model B is having just 2.09 million parameters, from 8 million to 2 million. That much reduction was seen in the size of the model, in the complexity of the model, by introducing this gap plus dense. Then what was the second change which I applied? The second change I applied at the layer of prediction. The prediction was dependent on greedy decoding. Now what greedy means? Lalchi. वॉट लालची कि वो हर एक फ्रेम पे देखेगा कि हर एक करेक्टर की जो प्रोबेबिलिटी है उसमें सबसे ज्यादा प्रोबेबिलिटी किसकी है, उस करेक्टर को सेलेक्ट कर लेगा और इस तरीके से वो पूरा सेंटेंस बताएगा। लेकिन अब वो सेंटेंस गलत भी हो सकता है क्योंकि हर एक फ्रेम पे अलग अलग करेक्टर की अलग अलग प्रोबेबिलिटी हो सकती है। तो बीम सर्च क्या करता है? बीम सर्च हर एक फ्रेम पे 4 से 5 करेक्टर की प्रोबेबिलिटी को साथ में रखता है। कब तक साथ रखता है? जब तक पूरा सेंटेंस न बन जाए, ताकि पूरे सेंटेंस के बनने के बाद वो ये देख सके कि सबसे सही सेंटेंस कौन सा है और उसको सेलेक्ट कर सके। In this way, I try to improve the prediction strategy from greedy decoding to the beam search decoding, where it maintains all the probabilities till the very last. So these are all the decoding strategies. Means the prediction decoding simply means which helps in prediction, which helps in converting the lip movements into the text output. So these were the decoding strategies which I developed. This was in the baseline model, and I developed this. And as you can see, the character error rate now, the character error rate which was in the previous model was 9.28%, means a character, it means that the deletion of characters was at 9.28%, and now it's just 3.01%. Then second, I trained 2 language models for guiding the model, and due to this the model, the I got the character error rate of 5% here. And third, I tried introducing completely new architecture. This was the architecture which I borrowed from the research paper. It had the character error rate of 9.28%, which was reduced to 4.7%. The 21% word error rate was reduced to 17%. And the major achievement was there was 75% reduction in the size of the model, and almost 49% reduction in the character error rate of the model, comparing from the previous model which I borrowed from the research paper to the model which I developed, which is currently known as Model B. So this is the complete. So in total, in my 6 months of hard work, I tried 11 different strategies, 11 different experiments. Out of it, what I got, the minimum character error rate stands at just 3%, and the minimum error rate from the model for just the model stands at 4.7%. So this is the architecture comparison which I just showed you, that from 9.28% to 4.7%, and 8.47 million parameters to 2.09 million parameters. Such the 75% reduction. And the major challenge which I was facing, the deletion error. The deletion error went from 98% to just 8% in the Model B. And these are the results which I want to show to you guys. The ground truth here is bin whited T3 soon. Now, what ground truth means? Ground truth means what the person is trying to say in the video. So, person is trying to say bin white at T3 soon. Now, what my model predicted? First, what the previous model predicted? Bin white at T3. Now you can see one E is missing, and soon ka it made sun with a character error rate of 8%. Just understand it. error rate of 8%, means out of 100 predictions, 8 predictions are wrong. Now, what model we did? Model we predicted bin white at T3 soon with the error rate of 0% here. Second example, which I can show you, is lay red by Z0, please. The my model predicted lay red by Z0, please, again with the 0% of error rate. Now, what we achieved in the last, what we achieved, the first we achieved the parameter reduction. Now, this model does not compromise with the accuracy. As you just saw, the accuracy of the model, the character error rate stands at just 3%. So, this model does not compromise with the accuracy. At the same time, it is very much reduced than the previous model. How much? 75% reduced from the previous model. Now, the second thing which I achieved under the guidance of the MEM, which is development of the new, completely new model architecture, which doesn't compromise in accuracy. The third is reduction in the character error rate and the word error rate. There is a flat reduction from 9% to 3%, 21% to 11% in error rate reduction. Now, this is the comparison. You don't need to just read it. I will summarize it in a very short form for you. It is a comparison between what I developed and what was developed in the 2016 research paper. What is the difference? Obviously, that was much more accurate than me, but uh, I used just 1,000 lines of data, just 1,000 lines of data. And how much data did the research paper used? 28,000 lines of data. They used they used the supercomputers for training the model. Also, they used the videos of 34 different persons, and I used the video of just single person. Why? Because I was having a single laptop, no supercomputer, no grant from the government, nothing. It was done on a simple Samsung laptop. So that's why I was have facing this resource constraint. But still, what is achieved, the accuracy is competitive to the what was achieved in the research paper, and that's what we brought to the table from the side of our country. Because most of the research done in visual lip recognition is limited to the European countries, where the developed European countries, and almost none of the research is done from India. So we brought this on the table, the word table from our country's side. So what's the future of the human communication? What the future scope? Multimodal communication. So I am not rejecting out the traditional ways of communication. You can question me out. What if your model is, what if there is no visual there are no visuals? How will your model will perform? I am not claiming that it will perform in all the situations, but what I am claiming is multimodal communication intelligence. Means what if we combine the speech, if we combine the visuals, if we combine the expression, the gesture, the lip movements, if we combine these four together, just think how well the communication will be, how well your information will be transferred to the another side. Second is assistive human AI interaction. Just think of the person who is speech impaired. He can't talk like I am talking with you. He will face some shame in the society. He needs to use some sign language. But with this, that person can also just speak lightning. How? Just by the lip movements. She can produce the lip movements, and by that the model can predict what the person is saying. The third is it will work in the silent and seamless communication. If I hope you guys are already aware of the Meta glasses, the smart glasses developed by Meta, Facebook, which was known as Facebook earlier. So if we just incorporate our AI model in the wearables, just think you are standing in front of me. The AI is scanning your lip in real time, and it is telling my ears what the person is saying. without you actually producing the sound. So that is the future of human communication possible if we incorporate AI in it. Now the final thought. I want to give a final thought. I want to leave with a here from with a final thought. Uh, Very great mathematician Ramanujan sir said that a equation means nothing for me if it doesn't tell me the meaning of God, if it doesn't tell a supreme meaning to me. Similarly, on the same lines, I tried to take out some insight from my research from this. Of it's a 6 months long journey, so I need to do something to engage my brain in it. So I try to take out two smaller insights from it. First is, as you saw, the model worked very well when it was associated with the guidance, the contextual guidance of a language model. Similarly, if in our life we have the guidance of our seniors, of our mentors, of the experience of the books written by some great personalities, then we can also perform very well from our current state in the society. The second insight which I drew from this research, that when I tried to change the complete model itself, it was not requiring any external help, any external language model. What does it mean? If I fix my mind, if I fix the problems inside, then I would not be needing the help, the external help, the external artificial motivation from outside. If I fix my mind, if I try to discipline myself, if I read some good superior things, then uh, I will not be needing some external help, some external fake hopes, some external fake artificial motivation which lasts just for 2 to 3 days. I will be naturally working in a disciplined way. Thank you so much, sir. Thank you so much, all the audience, for listening me so calmly with so much patience. Thank you so much, sir, and the GSTS team for this opportunity.
थैंक यू सो मच शुभ। सच में एक बार फिर से बहुत बेहतरीन वक्तव्य था आपका। एंड द लास्ट वन विच यू गेव वाज ऑन द topic finding solutions in chaos, where you have used Bhagavad Gita, if I'm not wrong, to generate some solutions in the chaotic world. And today you have used AI model, so that is really a very fascinating and a very good idea. Let's get some questions which have been arised from today's of your discussion. आप एआई मॉडल्स की बात कर रहे थे एंड यू वर टॉकिंग अबाउट कि लिप मूवमेंट्स किस तरीके से जो एआई मॉडल है वो इंटरप्रेट करता है और उस बेसिस पर जो है वो टेक्स्ट हमें निकाल कर देता है। Keeping in mind the Indian idea of language, where we have so many accents, where we have so many facial gestures, even कभी-कभी तो हमें बोलने की भी जरूरत नहीं पड़ती है, हमारा facial gesture से ही काम चल जाता है that somebody is angry or somebody is demanding something. तो अगर हम accents, facial gestures, इवन इट कैमरा क्वालिटी और लाइटिंग का भी ढेर सारा इफेक्ट पड़ता है। सो हाउ डज एआई हैंडल ऑल दीज वेरिएशंस?
Uh, Thank you so much. Uh,
Sorry, sir. Thank you so much, sir, for your question. Your question is completely genuine. How AI will work in such scenario when there is no lab set settings? Currently the model is getting trained on the videos which are shooted for that purpose only. So, sir, the answer is very simple, and it depends on the data set in which it is trained. It needs continuous training. So just for example, I will take example of OpenAI, ChatGPT. ChatGPT, Gemini, or Claude, it is continuously using your data, my data, others, all the person's data who are using it to continuously train itself. To continuously train itself on different varieties of data, on different diverse nature of the data. So what we need, that's why we need the data centers. That's why data centers are very much needed for the artificial intelligence. And government of India have I'm pleased that is also investing in data centers currently in Uttar Pradesh also near the Noida side. So that's why the training of an AI model is the most crucial step in all the process of the artificial intelligence model training. So how well your model is trained, how well your data is, that um, completely that completely makes how well it will perform in the real time, how well it will perform in the real time scenarios. Just for the example, sir, one example, the US crime something there is something crime analysis data something. So they analyze the data of criminals, and in that scenario they have some biasness in the data. Biasness matlab, the more number of criminals are from a single crime, due to which it impacts the prediction, where it highly impacts the prediction of that model. It predicts the most number of times, it predicts the same crime. Why? Because the data set was biased. That's why there is a complete field dedicated to development of the data before uh, getting the AI model trained on it, and that is known as data wrangling. Data wrangling, which is a field of data science. So data is the most important. For me, gold is not important, diamond is not important. Your data and other person's data is important. That's why the field of data scientist, the data science, is getting popular nowadays.
All right, that was really a you answered it really well. And one more question which arises that how this visual speech recognition improve communication for people with hearing impairments or speech impairments.
Okay, sir. So, sir, for that case, I just want you to imagine, just imagine that in my variables, if the AI is already incorporated, the model is incorporated, and just like Meta is developing the smart variables, then in the real time, it will using that camera, it will scan the lips of the person standing in just front of me. The speech impaired person knows. Because it he she can hear, so he she knows how to move the lips for a certain word, for a certain sentence. So if that person normally, just like me, moves the lips or try to speak, although the sound is not there, the model can scan the lips, and in the real time model can convert it into the text, and also that text can be converted into the audio, which can directly go into my ears or the ears of the person who is wearing that variables. In this way, it can help the speech impaired persons.
All right, that was really great, and thank you once again. And yes, of course, one more question which we always ask to our speakers, that how was your experience once again with this platform?
Oh, sir, because it was my second chance, it itself tells what my experience with this platform is. If I have repeated something, that means that it's highly valuable for me. It's something productive for me. So yes, I express my most humble gratitude to this platform for giving such a wonderful just opportunity for me. Even my professor, ma'am, Dr. Sarika Yadav, ma'am, encourages all her students in our class to participate here and to be a speaker, to try to be a speaker here on some topic. So yes, I am very much grateful to this platform, to Dr. Manish sir, to all the GSTS team for bearing me, handling me through this journey. I learned a lot, as always, as last time. And also, I will suggest all the audiences who are listening me to please try at least once to connect with this platform, to come here to try to speak. Dr. Manish sir will definitely give you the opportunity if he has given me the opportunity to speak 2 times here.
All right, thank you so much, Shobh, and that was really a wonderful session. Now, I would also like to invite Dr. our guest of honor for today's session, Dr. Sarika Yadav, ma'am, once again for her final remarks, for her final insights and thoughts on today's talk. Uh, ma'am, kindly unmute yourself, ma'am.
Yes, once again, I am very thankful to you, sir, and especially to Shubh, making me so proud. He had presented all his research work. Since 1 year, he is under my research guidance, and he represented so well all the data, all his research, that means at this platform where we are having different type of genres, like some students are from history, some are from economics, different variations of courses are there, and he's of computer science, and he represented his technical research so well that everyone is understanding it. That's really made me proud. And regarding this, a question you have asked, that how in India, how we can implement as by saying a simple word, we have different meanings. Like acha, acha is said. Acha can be said in various ways. But yes, actually, it is of a very great research. We have literally focused on, first of all, the lip movements. The second stage can be like in previous lecture, he had introduced neural networks. So by putting neural networks, we can identify the emotions behind the particular word, we can associate it with, and we can build another model. Means every time you have to bring a build up a model for this particular implementation. Like he said, he had worked on 2.9 million features. Again, some few features have to be added every time the model has to develop. And yes, his laptop was like in a dying state when he was experimenting it. And every time he will run in, Ashki, ma'am, I'm very much upset. The results are not coming. Only 30 outputs have been generated, and so and so. And it's okay. What we can do? The government is not providing any aid for the research to our students. Our students are really having a very good brain, but maybe someday we have this opportunity to provide students. Then I think you have purchased Google Colab too. Have you purchased Google Colab for the experiments?
Yes, ma'am. I
Oh,
did. Two,
so
three
like
times,
this,
ma'am.
yes, 3 times he had to purchase, and for 1 month I think it charges approx 1500 rupees.
Yes, ma'am.
So
1,500 to
that
2,000.
yes, 1500 rupees. But this research is really going to take a major form, and I will say that should go for the patent. Okay, you can apply for a patent on this research, and of course, this platform has given a vast confidence to Shubh, especially because representing such ideas is a big task. You don't know whenever your things may get abrupted, like last time the thing happened. In a, well, that was a example. He creates such examples. Today he suddenly muted himself to just show how this lip movement can be analyzed, can be recognized. So that's very good and very nice representation by him. And of course, future AI is going to hold this part of research also, like social robots. They will read the facial speech. These social robots provide emotional support to aged peoples or person who are lonely, so they can use this concept. Then we have conversational AI systems like chatbots. Like simply we are typing the text and getting the answer. Later on, we simply can communicate through our lip movements. For deaf peoples, it is like hearing without ears. Lip movement can be read, and the text will be produced in front of them. And the context means, like we are saying the word blue, blue as well as Q. They have same pronunciation, and the lip movement is almost same. Then in this field again we have to work a lot, because right now we are just converting the voice into the text. Not, I will not say the voice. It is simply lip movement, but this lip movement is also captured through mapping the voice, but later on we will map it with expressions. Means what are the expressions in the statement hidden, so that can be improved much better later on, and various communication factories are working on this field. So that's all for today. Thank you so much again for inviting me, Shubh. In spite of my busy schedule today, I had just came, and so sorry for yesterday as I was in flight. That moment you were communicating with me, so but yes, today's was really very important for me to join this and reunited with this platform again and again. Thank you so much. Thank you.
Thank you, ma'am. Thank you so much that you have joined us today and you have shared your valuable insights and thoughts regarding today's topic. So thank you so much, ma'am, and thank you so much, Shubh, as well, for your wonderful depiction of your topic. Now it's time to wrap up the session. And again, it usually happens with GSTS that nowadays, because of the examinations, also that we are not, getting a next speaker in this series of reconnection. But it doesn't mean that we will get the next speaker and it will continue again, and we'll surely meet on next Sunday. And now, to wrap up the whole session and to give vote of thanks, I would like to hand over the screen to Dr. Manish Karnwar, sir.
Uh, Thank you, Silence. My voice is clear, I think so. Not due to only the examination, university examination, but the UPSC also. I think next Sunday is the UPSC, but this is the point. uh, we are having air, water, food. So why we interrupt this? For this, we are not doing this. For this, not do we are doing this. So this is some excuses whatsoever. Uh, Today's session again, the soup session. Though I'm right now very busy with my few 4 and 5 scholars in front of me. So we are discussing some India Africa Forum Summit and what we'll do, what will not do. But really, it's a fantastic idea. So, last day also we had a discussion, pre-meet discussions. So, definitely, if we solve some social issues, because what the science, the commerce, the arts, and the social sciences, we created a difference. And you, Salendra, and this forum like GSTS, uh, try to little bit fill the gap, but it's very difficult because you tried your level best, but I did not get few points because I'm not that trained to be a data scientist or the data, because we are social scientists. And you know the what important thing is, like you are talking about the data. So in the science, data is important, and the social science data is also important. That the EHCAR and the so many scholars, not EHCAR, the data is just like a raw material. How you use that data, it's a very important thing. So social science is also using data, but where is the common ground? Because those who are having data, they become powerful. You look the Iran, that's why USA wanted to dismiss Iran's idea. So data is power, but the most important thing, what we using data, the main source is goes where, that means the who generate and who deposit all this data. And this is the settling point for everyone, for whole ideas. कौन डेटा अपने पास स्टोर कर रहा है, किसके पास स्टोरिंग कैपेसिटी है. So next 10 years will be going to, and that's why the Arab countries and the small countries in Africa also, I think Uganda or Rwanda, they want to create a data storage center. So whole country is doing the same. Despite the social work, they are using the data storage, because as Subh know, for the data storage we need water, cooling, etc., etc. But what you are talking about, Subh, is entirely different thing, and that goes to a line where the person with a disability can understand the things. It's a very appropriate. So, which if we complete those things, it will be very beneficiary. But every thing has two ideas, positive and negative. So in the future, think so. And if anybody, scientists are using this device, so the first priority, that how we use positively. So I think so. This is my idea. I do not know. Yes, one more thing, that in the AI field also, suppose that I'm looking this. So maybe I look like angry, but maybe I'm looking at my keypad things. So this because I had a very good article, and I think I reiterated the same thing the last discussion also. So suppose like this. So I'm not angry. I'm trying to looking out the icons on my table. So these are the things. So we are very careful when we work on data and a data like system. So, 1 minute. Okay, so data like system. So this is only one idea that we have to careful to monitor, but we give some smile to others. It's a good gesture. So I know you from last so many months, so you can give us a sense, give us the India or the world a good idea how to cherish all these development, because every development has two sides. So we'll try and give the new ideas in this platform, that where we had collaborate science and commerce and economics. So try to catch up the whole idea about the education and about the new perspective. So thank you, sir. And madam, thank you, Dr. Sarika ma'am, for your wonderful gesture to come. And usually I invited each and every guest of honor, but somehow it's Salent's idea and the Sub's idea that why not again the Dr. Sarika ma'am. So thank you, ma'am, for your wonderful depiction and wonderful idea and how you nurture your students. So thank you very much. And Salent, always grateful to listen to you. Your examination is also around, but you are here, and Sub examination is also around. So it's not examination, Salent. It's there are so many other things which these days university or students are involved in, because working is a energy for a student or for a teacher. I never tired of a work. So thank you, my scholars, principal, IQS in charge, teacher in charge, and faculty from the Samuel Evening College for the coming. So thank you very much. In the next Sunday, no Sunday is going to be blank Sunday, or so definitely one should come and speak. Otherwise, my moderators are enough capable to do the good gesture. So thank you very much. Have a nice day. We'll meet next time. Okay, so thank you. All the best. Thank you.